Hi, dear student. Let me discuss about interrupts. This is the most interesting and important concept in any microprocessor or microcontroller. We should learn about what is interrupt, how we can call the interrupt with respect to our applications, and how we can give the priority with respect to our interrupts. Basically, interrupt in the sense some application is going on to interrupt to that application, like instantly you want to stop the application or give the notification to the application. This is what probably the main basic concept of interrupt. So the interrupt refers to a notification communicated to the controller by a hardware device or software, on the receipt of which controller momentarily stop and respond to the interrupt. See, the concept is simpler. It is give the notifications to the controller with respect to the hardware device or the software device. The controller momentarily stops and responds to the interrupt. This is what the concept. Next we'll see the what is an interrupt. Whenever an interrupt occurs, the controller completes the execution of the current instruction and start the execution of an interrupt service routine or interrupt handler. So the concept is simpler. Whenever interrupt is occur, controller complete the execution of the current instruction and start execution of interrupt service routine where you saved the program in the ROM area. See, interrupt service routine is written in the ROM. Let's say we have a 4K ROM. In each ROM, it has specifically says, let's say this is your reset, and we have the sum of the interrupt like timer interrupts, and we have the serial communication interrupt, and we have the hardware interrupt like interrupt 0, INT 0 and INT 1. So these timers address in the ROM area whenever the interrupt occur correspondingly with all these interrupts. So then it goes to the service routine. It is written the program with respect to application, or it going to be handle the system. ISR is a piece of code that tells the processor or controller what to do when the interrupt occurs. It is a routine in the sense it is a program written in your ROM area. Whenever interrupt is occur, then your program counter has jumps to the ISR routine and it is executed that program and tells the processor or controller what exactly you want to do with respect to the application. After execution of ISR, controller returns back to the instruction it has jumped from the ISR routine. The interrupt can be either hardware interrupts or software interrupt. The interrupt can be either hardware interrupt or software interrupt. We have the two interrupts. Let me discuss with the simple example. So this is my controller, ARM controller. I connected to a keyboard as well as my LCD display. See, this can be read and write we can do through your keyboard. I can give the input to the controller. Okay, and this is the LCD display. This can be output. See, the controller or the process has to simultaneously by taken the read the input or write the output to the LCD screen instantly. It may, whatever your data can collide or lapse the data in between. That time your controller may have hang the system. What I supposed to do? I have the interrupt, like a reset interrupt. I can reset the system, or in between I can call some of the interrupts to stop the reading or writing by your keyboard or the LCD screen. This is how we can use the interrupts. Why we need interrupts? Controller interact with the inbuilt devices like timers and other interfaced peripheral like sensors, serial ports, etc. The programmer needs to monitor their status regularly, like whether the sensor is giving output, whether a signal has been received or transmitted, whether timer has finished counting, or if an interface device needs service from the controller, and so on. This state of continuous monitoring, that is what we call it as polling. See, system like my brain, my controller is like brain. I want to view, I want to do some work in my hand, I can walk. See, all these process my brain has to be monitoring in instantly or regular time. It is like a routine time. Every time I need to check what my hand is doing, what my legs are doing, what my eyes are doing, what all my peripheral like connected to the microcontroller, sensors or any other timers, how these things are working. This is known as polling. Continuously monitoring the peripherals. So that I need to service these devices. That's why I required interrupts. So now comes to the polling. The microcontroller keeps checking the status of other devices. While doing so, it does no other operations and consumes all its processing time for monitoring. This problem can be addressed by using interrupt. It means that the microcontroller always checking the status of other devices regularly. That is what we call as a polling or pooling. Let's see the simple example. I started the timer TR0, timer 0 I started. So when the timer reached the maximum count, until that I need to check. See, my timer has 8-bit, in the sense it is started from 00 to FF. It reaches that. I want to check when my timer has reached the maximum count. How am I going to check this? That continuously check the interrupt. I am going to be creating one interrupt here, that is timer flag 0, that is for the interrupt for timer 0. Whenever the timer flag is set, then it indicates that it is rolls over. It means that it reached the maximum count. It reached the maximum count. Then automatically clear your all the timers register as well as the flag. So this process here, I am checking every time the timer flag until my timer flag will be set, then I stop my counting. So this is the process we call as a polling. It's a simple example. Next, see, in interrupt method, the controller responds to only when an interruption occurs. Otherwise, your controller never going to be stops. Thus, in interrupt method, controller is not required to regularly monitor the status like flags or signal, etc. of interfaced and inbuilt devices. Remember, once the interrupt occurs, then only your controller has stops. Until it's never going to interrupted in between your controller. And that time, if you are adopted the interrupt, your controller does not require to monitor the status of the flags or the signals. Like, I want to tell you the difference between polling and the interrupt. See, the person, salesperson, every time he is coming to individual houses and telling that this is his whatever his items, called as an items, for delivering each individual houses. He going and knock the door and interrupt the person and telling that, see, this is my items. If you want to purchase this item, you can purchase, and these are the offers are available. And the same way, I can give one more example, like the person go to the mall and all the items are present at the same instant. Whatever he can purchase instantly, whatever he wanted. See the difference. So here the person is going to individual houses and interrupting and selling his item. Here the controller monitoring, like check all the items and purchase whichever they wanted, and billing the end, and it will come out of the shop. So that is what the polling. And interrupt in the sense, every time it is going to individual houses and interrupt the person and selling the concept. This is what the difference between the polling and the interrupt. So as we told that we have the two interrupts, hardware and the software interrupt. If the interrupts are generated by the controller inbuilt devices like timer interrupts, or by the interface devices, they are called the hardware interrupts. Like, see, the controller have the inbuilt timers interrupts, or some of the interface interrupts like INT0 or INT1. See, these are we called as an hardware interrupts. If the interrupts are generated by a piece of code, they are termed as a software interrupts. Like, I can write a program to do some application once this exception has happened. so that whatever I written the code to terminate or the stop or generate some signals, that is the software interrupts. So 8051 we have the 4 interrupts. Reset, normally we not called reset as an interrupt, remember. Okay, and we have the timer interrupts, external interrupts and serial interrupts. Normally in 8051 we can call the reset as an interrupt, but if you go for the higher controller like ARM controller and all, we are never going to say the reset as an interrupt. Okay, but we'll see reset as an interrupt, timer, external and serial interrupts. See, reset interrupt, as we know that simple. If your system is hanged, what are you supposed to do? You try to come out of the application. If not, then automatically you need to restart your system pressing the reset button. So that's what this is known as a power on reset, POR, like switch off and switch on. So it's simple. When the reset interrupt is received, the controller restarts executing code from 000H location. At the time all the content of your data and the memory content or the register content all will become 0. It is refreshed, it is fresh controller when you press the reset button. Similarly, we'll come to the timer interrupts. See, we have the 2 timers, timer 0 and timer 1. Each timer have the interrupts. Like each timer is associated with a timer interrupt. A timer interrupt notifies the microcontroller that the corresponding timer has finished counting. Normally timer 0 I started, with some amount of delay I generated. After delay overs, the timer has to stop, or it rolls over to the reset or 0. How it comes to that? I set the flag. For timer 0 I set the timer flag 0. Timer 1 I set it for timer flag 1. So these 2 are the timers interrupts. See, we have an external interrupts. There are 2 external interrupt, EX0 and EX1. To serve the external devices, both these interrupts are active low. That means active low. It is zeros. Probably in 89C51 microcontroller, in port 3.2 we have an INT 0 and port 3.3 INT 1 pins are available for external interrupts 0 and 1 respectively. Remember, whenever we are going to access the external interrupt, we can connect it through the port 3.2 and port 3.3 to enable or disable it. An external interrupt notifies the microcontroller that an external device needs its services, like external hardware interrupt, INT 0 and as well as INT 1. And last we have the serial communication. Like we have in serial communication we can transmit and receive the signals. When enabled, it notifies the controller whenever a byte has been received or transmitted. Once it is received or transmitted, how I can come to know that? That is the interrupt. That is receiver interrupt as well as the transmitter interrupt. RI and TI. We have 2 serial communication interrupts. How is an interrupt serviced? How this will be works? Okay, so that will be seen in the next class. Thank you very much.